Now today's topic, let's start the rotation motion. It is also be in textbook, it is named as system of particles. What it is? Now in this, the first foremost point you need to understand is moment of inertia. What you need to understand? Like it is a mass in a linear motion. See, there will be two types of motions, actually. Linear motion and rotation motion. So in linear motion, we call it as mass, right? We call it as mass is inertia. Mass is mass is inertia. In rotation motion, we call it as moment of inertia. We represent with I. So same definition. You see, moment of inertia is body's tendency to resist the angular acceleration. And what is mass? It is a tendency of the body to resist the linear acceleration. Okay, clear? Chalo. What is I? I is a product of I is a product of mr square, mass into its radius whole square. R is the distance. Let's understand what is these terms are. Everything we will understand. Okay. Let's take a first example of point mass. What is a? Let's take one point mass. Ashla. See, uh, imagine there is one point mass there of mass m. Clear? Which is tied to this axis. To this axis, it is tied. This mass is tied. Okay, and it is rotating. And this axis we are rotating. Like this is your hand. This is your hand. Imagine, and this is one thread. It is rotating. It is understand, right? It is rotating now. It is moving a circular motion here, rotational motion here. Now, what is its moment of inertia? I is m is the mass of the object, clear, and r is the perpendicular distance. What is r? R is very important. What is r? R is perpendicular distance of mass m from the axis of rotation. Okay, what is the axis of rotation here? Your hand is the axis of rotation. Okay, so from this line, how much perpendicular distance is? That is your mr square. Understand? Let's understand with very nicely with one good example we will take. You see, Astra, there is one rectangle. Imagine, not it is a rectangle. The masses are arranged in the shape of rectangle. Here mass m1 is kept, here mass m2 is kept, here mass m3 is kept, here mass m4 is there. All are point masses. All are point masses. Now if I say I am rotating this rectangle about this axis, this is my axis of rotation. Clear? From this axis, you are rotating in this way. You are rotating this in this way. Now, how it will rotate? Like this is rotating, right? Here it will come like this. Correct? It will be rotating in this way. The entire rectangle is rotating. Now, basically, how many masses are rotating? Two masses. Excellent. M1 and M2 are rotating. M3, M4 are along the axis. So moment of inertia of M3 is equal to 0 because R is equal to 0, perpendicular distance is 0. It is on the axis. And in the same way, moment of inertia of M4 is equal to 0. It is also perpendicular distance is 0. Now only M1 and M2 will be. So moment of inertia of M1, tell me the formula. M1 into, let this is the length which is perpendicular from the axis of rotation, right? It is ml square. And what is moment of inertia from M2? It is M2 L square. What is the system moment of inertia will be? Add all. What it becomes? M1 L square plus M2 L square. You can take L square common. What it becomes? M1 plus M2. Is that clear? This is your moment of inertia. Just now we completed point mass, moment of inertia, correct? Now ring we will see. Ring, you know, right? It is like cycle ring. It is like a cycle ring. Here is a cycle ring which is kept on the plane, horizontal plane. Now I want, so this is the axis of rotation I am rotating. This is, now the ring is connected in this way and it is rotating like this. Understand? The ring mass is capital M. So this is the axis of rotation. This is axis of rotation. Axis of rotation about what, where it is passing, about the center of the ring. Axis of rotation is about the center of the ring. Then in this case the moment of inertia formula mr square. What is the formula? Mr square. R is the perpendicular distance, that is your radius, that is your radius of the ring. Clear? What is R? R is the radius of the ring, m is the mass of the ring. Okay. If it is a ring, if it is a ring, I greater omega smaller. Now, or hollow cylinder also same. Hollow cylinder also same formula. Hollow cylinder also same formula. Hollow cylinder also same formula. About this is the axis of rotation. About this axis of rotation, because it is also same type, you see, same formula. Or it is a half disc is there, only half disc is there, only a part of the disc is there, this part is not there, only half disc is there, then also same formula. Then also a quarter disc is there, irrespective of it. Mass should be capital M. This mass is M, and which is at center, the axis of rotation is about this axis of rotation, it is rotating, it is of radius r, same formula. Even a quarter disc you take, one quarter, 1/4 of the disc you take, same formula. Any part of the disc, ring, sorry, not disc, sorry, ring, any part of the ring which has mass m, radius r, mass m, radius r, moment of inertia formula mr square. Okay, clear? Okay, now ring clear, right? Ring formula mr square. Now if it is a disc, if it is a disc, you see, disc means what, you know? What is the difference between ring and a disc? Huh? Don't know. Array, disc means a CD disc, did you see any time? It is a solid, like it have area. Cycle ring, you know? Car, this is car wheel, you can imagine. This is cycle wheel, imagine. Again, this is the center of the disc, and this is the axis of rotation. Same concept, you see. Mass m, radius r. But here the moment of inertia mr square by 2, because mass is distributed. Okay. Now my question is, both of, for example, ring and disc are there. Ring and disc are there. Both of same mass, same radius, everything is same. What do you think? Which one rotates faster? Disc rotates faster. Momentum conservation. Do you know in the linear momentum conservation? You know, huh? In the linear, if you know momentum conservation, that is mv is a constant, correct? mv is a constant. If you apply for rotation, still we have this concept next. I am saying mass is inertia, that is I, moment of inertia, and velocity we call angular velocity omega. I omega is a constant, right? If I is greater, omega is smaller. If I is smaller, omega is greater. And in these two, ring and disc, whose I is smaller? Disc, correct? If disc I is smaller, so omega will be greater. That's why cycle wheel is had spokes for the safety, because cycle should not move faster. Safety purpose, it is designed in that way. Bike also, you see, spokes it have, because it is designed so. Understand? If moment of inertia is smaller, omega is greater. That's the practical design. Clear? Now again, same concept. Half disc you take, same formula. Quarter disc you take, same formula. Okay? It can be half disc. It can be half disc, which is rotated like this, whose mass is m, r is this. Then also same formula. Okay? Then also same formula. It is mr square. R, this is cylinder. What cylinder? Solid cylinder. This is hollow cylinder. Ring and hollow cylinder. Ring and hollow cylinder have the same formula. And here solid cylinder have the same formula. Is that clear? What is the formula? mr square by 2. As well, one more is there, cone. What matter? Cone. Hey, hollow cone. What cone? Hollow cone. Hollow cone also same formula. Formula what? mr square by 2. Okay, this sheet you will find in the description. So all the formulas. So point mass, ring, disc completed. Solid cone. If it is a solid cone, 3 by 10 mr square. What is the formula? 3 by 10 mr square. Solid cone clear? Now sphere. Hollow sphere, solid sphere. One is hollow sphere, you know. What is sphere? It's a 3D ball. It is a ball. First hollow sphere, formula 2 by 3 mr square. This is the angle of axis of rotation. And solid sphere. Next what? Solid sphere. Solid sphere formula 2 by 5 mr square. This is solid one. Difference you know? Okay. Solid sphere. Now most important is a rod. What is this? A rod of length L is given. What is the axis of? What is the moment of inertia? Now you hold pen in your hand, you will rotate, right? Correct. This is the axis of rotation. That time in the middle we will hold and we will rotate. Then the moment of inertia formula mr square by 12. What is the formula? mr square by 12. Now if you hold the same pen at this position and rotate, it is mr square by 3. It won't, which here it rotates slowly, here rotates faster, because I is smaller, omega larger. Here I is smaller, omega larger, I greater, omega smaller. Okay, chalo. Now the same question given with the rectangle, same concept. If this is rectangle also, it is like a rod only, right, of length L. So it is also formula mls square. Length na, it is not r here. mls square. What it is? mls square. Here mls square by 3. Here also same, mls square by 3, mls square by 12. At the center, this is the center of the rod. This is the center of the rod. By chance, if they ask you at this position, this is breadth B, then what is the formula? It is mb square by 12. At this position, if they ask, it is mb square by 3. Okay. By chance, if it is if there is some different shape there, any shape is there, who make cavity? Cavity, you know, cavity means hole. Cavity means here is a cavity. Whenever cavity question comes, moment of inertia without cavity you find out. Moment of inertia of the cavity you find out. First one without cavity, next cavities one you find out. Then I is equal to I1 minus I2, simply you apply. Okay, na? Clear? So today moment of inertia we have seen. And this point masses, what is the formula? mr square. M is the mass and r is the perpendicular distance from the axis. Next ring mr square, disc mr square by 2, solid cylinder mr square by 2, hollow cylinder mr square, hollow cone mr square by 2, solid cone 3 by 10 mr square, hollow sphere 2 by 3 mr square, solid sphere 2 by 5 mr square, rod at the center it is mls square by 12, at one end it is mls square by 3, rectangle also same formulas, mb square by 12, mb square by 3. If cavity is there, I1 minus I2. Clear? Now today's topic, parallel axis theorem. What is the importance of parallel axis theorem? Now just now we have learned there is a ring, right? Okay, ring moment of inertia we know when the axis of rotation is across the center, correct? When this is the axis of rotation and your ring is rotating about the axis of rotation like this ring is rotating something like this, correct? Then the ring mass is m, and the radius is r, then we have the formula I is equal to mr square for the ring. But this is valid only when the axis of rotation is passing through the center and perpendicular to the plane of the ring. Correct? But in case, in the exam hall, if they ask what is the moment of inertia about this axis, then how it will rotate? It will rotate around this, right? You imagine that you take a pen, right? And you see, put one bangle to the pen and rotate it. So that is the rotation here. Did you understand? So how it will rotate around this pen? It will rotate. Now here, if I ask you the moment of inertia, can I apply this formula? No. This formula is applicable only when it is passing through the center of the mass, I center. These cases and these kind of cases comes in exam, then moment of inertia you can find out. Correct? Understand? Then I parallel axis theorem says that I at any point P, that this is point P, is equal to, you should know I at center of mass plus m d square. D is the distance. D is the distance of the point from the center of mass. From the center of mass. Now you see, I know this distance now from the center of mass. How much is this distance? R. Now right now in this case R it is. So I at point P is equal to, I at center of mass I know how much it is, mr square plus I at this md square, right? M into this is r square. So I at this point P is equal to 2 mr square. So in this way you can use this parallel axis theorem. So now the topic is perpendicular axis theorem. What is perpendicular axis theorem? How we can use it to see? Now we have a ring right now. So when, if it is rotating about the center, this center of mass, which is perpendicular to the plane of rotation, then we know the formula I is equal to mr square. We found now at this point also. But now the question is, if it is, if the pen is kept here, if I am rotating on this axis, then it is something like this. Imagine this is a circle there, a ring there, right? A ring, for this ring I kept something like this, passing to the center, passing to the center. Then what is this I is? It is, you see, something, the r about here, this is x axis you can say, this is y axis you can say, and we know about the z axis. Correct? So you see, this is my x axis. What I am saying is, this is my x axis, this is my I around on the x axis, and y axis is something like this, right? This is about the y axis you can say, this is about the y axis you can say, and this is the I about the y axis, and these are the things, and z is upon, on top. Perpendicular axis theorem says that Iz on the z axis is equal to Ix plus Iy. Okay. Now how we will use this, you see now. So we know on z axis, right? How much it is we know? Mr square is equal to, I am asking it on x axis, and x axis and y axis are equal. You see, mass distribution is same, distances are also same. So here I can say, when I ask for x axis, they can write 2 simply, right? Correct, good. So I can say I along x axis is equal to half mr square, correct? Or if they ask even for y axis also, same, mr square by 2. Correct, understand? So in this way you can use perpendicular axis theorem. So this is the use of parallel axis theorem and perpendicular axis theorem. Mass m, radius r. This is a mass m, radius r. Cavity has cut of r by 2. Gravity has created r by 2. Find the moment of inertia about the center of the sphere. Okay, fine. So I final, this is I of without cavity, let it be I total minus I of cavity. So first without cavity, with cavity. Consider there is no cavity at all. So moment of inertia passing through the center formula 2 by 5 mr square. Total mass is m r square. So what is this value? This value we got IF is equal to, without cavity we got 2 by 5 mr square minus I of cavity I want. So you made a cavity of r by 2, right? I of cavity is equal to, it is also 2 by 5, but mass is not capital M, it is some mass that we will find out. Mr square r by 2 given r square. So I want this is small m, mass is equal to density into volume of the cavity. I know the density, density is equal to, see what is the density, this is mass, this is radius, right? Density is equal to total mass by volume of the sphere 4 by 3 pi r cube. This is the initial density. From that density I want, this is the volume of the mass we have, right? Again 4 by 3 pi r cube by 2 cube 8. This is volume of the cavity. 4 by 3 pi r by 2 whole cube, r cube by 8. See 4 by 3 pi r cube, this 4 by 3 pi r cube cancel. So small m I got is capital M by 8. Substitute here. This is 2 by 5, capital M by 8, r square by 4. 2 table you can cancel 2 times. Finally I got cavity in the moment of inertia mr square by 8 40 80. So I moment of inertia or something. I think this is the answer. Like chalo, do it. This is cavity. How much we got? Mr square by 80. So 80 is the LCM. 16 to the 32. 32 mr square minus mr square. This is 31 mr square by 80. Option 2 is the correct answer.